This is General Chemistry, cover the topic of gas, part 8. Today we will be looking at gas reaction and gas stoichiometry. When we talk about gas reaction, we will look at a reaction that at least one of its involving species is gas, and that species can be reactants, products, or both. Let's say we have a reaction A plus B forming C plus D. A and B are reactants, C and D are products. And if the species A, B, C, or D is gas, we will consider this a gas reaction. When we come across a gas reaction, there are at least two things to remember. First, we need to balance that chemical reaction. If it looks like it's already balanced, we need to check it. Second, if we need to link between certain species in the reaction, we need to use mole. But many times the questions may not give us mole directly. That means we need to know how to convert between moles and the given information. For example, they may give us a volume of gas. To convert that to mole, we can use PV equal to nRT, which means N or mole will equal to PV over RT. That means if we know pressure, volume, and temperature of that gas, we can get mole. Sometimes they may give us volume of gas at STP, or standard temperature and pressure. We know that 1 mole of gas at STP will occupy 22.4 liters in volume. To convert that to mole, we can divide the volume in liter by 22.4. But sometimes they may give the information in mass instead of volume. To convert that to mole, we can divide mass in gram by the molecular weight or molar mass in gram per mole. Now that we learned some concepts from gas reaction and stoichiometry, we can try some practice questions here. For this one, reaction of calcium carbonate with hydrochloric acid release carbon dioxide gas, and that is the equations. How many liters of carbon dioxide gas will be produced at STP if 75 grams of calcium carbonate reacts with excess HCl? First, we should confirm that the reaction is balanced. So what they give us is calcium carbonate with 2 HCl gonna form CaCl2 plus H2O plus CO2. In order to confirm that, we can list all the elements involved. We have calcium here on the left, and then carbon, oxygen, hydrogen, and choline. And then we list the same thing on the right: calcium, carbon, oxygen, hydrogen, choline. And now we check. On the left part, we have 1 calcium, and then 1 carbon, and then 3 oxygen, and 2 hydrogen, and 2 choline. And on the right, we have 1 calcium, 1 carbon from carbon dioxide, 3 oxygen because 1 from water and 2 from carbon dioxide, and then 2 hydrogen from water and also 2 choline from calcium chloride. So once all the elements match, we can confirm that this reaction is balanced. The second step is to identify the involving species and link them using mole. So the involving species are carbon dioxide gas and calcium carbonate. Alright, so let's try that. So calcium carbonate here and carbon dioxide here. So now we have to relate them by mole. For calcium carbonate, they give us in gram, and mass of calcium carbonate is 75 grams. In order to convert it to mole, we can have N equal to mass over molecular weight, and mass is 75, and molecular weight is, for calcium it is 40, for carbon it is 12, and for oxygen it is 3 times 16. So that's gonna give us 100. Alright, so it's gonna be over 100. So this is gram and this is gram per mole. So we're gonna get 0.75 mole for calcium carbonate. To find carbon dioxide, we can relate that to calcium carbonate by mole. We know that 1 carbon dioxide and 1 calcium carbonate from the reaction gonna be equal to mole of carbon dioxide over mole of calcium carbonate, which is 0.75 mole, which means mole of carbon dioxide is gonna be equal to 0.75 mole too. But they ask us for the liter, which is volume of carbon dioxide gas at STP. We know that mole at STP gonna be equal to volume in liter divided by 22.4. So if we need volume of carbon dioxide at STP, it can be equal to N times 22.4. So it's gonna be equal to 0.75 mole times 22.4. And that's gonna be 16.8 liter. And that is the answer. Alright, let's try another question then. For this one, cells rely on aerobic respiration for a production of energy. This process is sometimes simplified by using the chemical equations for the combustion of glucose. How many liters of carbon dioxide gas should be produced at 1 atm and 37 Celsius if 4.5 grams of glucose is consumed in the process? For this one, they don't even give us any chemical equations. They just say that this process can be simplified by the combustion of glucose. So we first need to write down the combustion of glucose. We know that for glucose it is C6H12O6, and for the combustion it means it reacts with oxygen to give carbon dioxide and water. Let's balance one thing at a time. Starting with carbon, we have 6 carbon here, so we can put 6 over here on the right, and then we have 12 hydrogen here, so we can put 6 over here on the right. And now we have oxygen left, but we can see that from here we're gonna have 12 oxygen plus 6 oxygen from water, which means it's gonna be 18. Alright, from the left it should be 18 too, but then they have already 6, so 18 minus 6 is gonna be 12. So over here it should be 6, and that should be it. Now we should confirm that it actually is balanced. So we list CHO over here on the left, and we also list CHO over here on the right. So for carbon we have 6, and then for hydrogen we have 12, and for oxygen we have 6 plus 12 is gonna be 18. Alright, for the one on the right we have 6 carbon, we have 12 hydrogen, and also we have 12 of oxygen plus 6 of oxygen is going to be 18. So all the elements match. That means this is balanced. The next step is to identify the involving species. So they ask for the liters or volume of carbon dioxide gas. So that is one species. And also they talk about 4.5 gram of glucose. So that's another species. Alright, so we have glucose here and we have carbon dioxide here. Now we have to relate these two by mole. They give us 4.5 gram of glucose, so that is mass. And we know that mole gonna be equal to mass over molecular weight. So it's gonna be 4.5 gram up here. And for glucose, the molecular weight is gonna be 6 times 12 for carbon plus 12 times 1 for hydrogen plus 6 times 16 for oxygen, and that's gonna give us 180. So we're gonna be dividing 4.5 with 180 gram per mole, and that's gonna give us 0.025 mole of glucose. And from the reaction we can say 6 of carbon dioxide with 1 of glucose. Alright, and it's gonna be equal to mole of carbon dioxide over mole of glucose, which is 0.025 mole. Alright, so we're gonna get the mole of carbon dioxide to be 6 times 0.025, and that's gonna give us 0.15 mole for carbon dioxide. But they ask how many liters of carbon dioxide gas. That means they're looking for volume. We know that PV equal to nRT. So to get the volume of carbon dioxide gas, we can set it to be equal to nRT over P. So N is 0.15 mole, R is 0.082 liter atm per mole Kelvin, T is 37 Celsius, which is 310 Kelvin, and pressure is 1 atm, and that should give us 3.813 liter, and that is the answer.